Hi, in this video we will understand the application of hydrometer in our daily life. So we'll understand the application of hydrometer in our daily life. So what is a hydrometer? Basically, hydrometer, it is one of the apparatus which float above the surface of water, and it is used to determine the relative density of liquid. So it is the floating instrument which is made purposely in order to float above the surface of water, and it is used to measure the relative density of liquid. So the hydrometer, it consists of the bulb, which is very thin. It consists of the bulb. This is it consists of the stem, which is very thin. This is a stem, which is very thin, and it also consists of the bulb. Now, inside the bulb, basically the lead shorts are introduced. These are so-called lead shorts, and the purpose of introducing the lead shorts inside the hydrometer, it is just to make the hydrometer to stay upright above the surface of water, because as you put the lead shorts, the hydrometer becomes heavy and it can displace large amount of water, so that you can measure the relative density easily. All right? Okay. But also, as we said, that it consists of the stem, and inside the stem there is a paper which is graduated with density. So inside here there is density paper which is graduated with the scale, starting from the smallest number at the top. For instance, this is 0.8, and as you go downward, the number keeps on increasing. This is 0.9, this is 1.0, this is 1.1, this is 1.2, and so on. So inside the stem, there is the paper which is graduated with the different densities that ranges from the smallest to the largest. The smallest at the top, and it ends with the largest number at the bottom. This is 1.2, and so on. All right? Okay. Now, one thing here to understand, that basically the stem of the hydrometer is made very thin. Why the stem is very thin? Why the stem is thin? The stem is very thin in order to allow the greater changes in height for the very small change in density. The stem of the hydrometer is made very thin in order to allow the greater change in height for the very small change in density. And we can understand this by saying that we know density is mass divided by volume. We can also write mass divided by volume. It is area times cross section. It is area times height. So we can write density is equal to mass over area bracket times 1 over h. Now, if mass over cross section area is constant, we can write that density is basically inversely proportional to height. So as the height changes more rapidly, it means the density will change very slowly. That's why the stem of the hydrometer is made very thin, in order to allow the greater change in height for the very small change in density. All right? Okay. Now let us see the working of the hydrometer. How does the hydrometer function? Basically, the hydrometer is made to float in the liquid whose relative density is to be determined. For instance, you can take the tall jar what you do, you take the tall jar. This is a jar which is very tall, and you put inside this tall jar the liquid of which you are intending to measure. So you can put, for instance, kerosene, you can put water, for instance, you can put some water here. And then what you do, you take now the hydrometer. You place inside this tall jar which is full of water. So you take the hydrometer, which looks like this. It is having very thin stem. So you place inside this tall jar until it floats freely. Remember, it is having the number which ranges from the smallest number at the top, and as you go at the bottom, the number keeps on increasing. For instance, here there is 0.9, there is 1.0, there is 1.2, and so on. So you take basically the hydrometer, you place it inside the tall jar, and you leave the hydrometer to float freely. Now you record the point on the stem of this hydrometer which correspond to the water surface, to the water surface in this tall jar. Now, for instance, you can, after putting this hydrometer inside the tall jar which is full of water, you basically now record the point on the stem of this hydrometer which correspond to the water surface. For instance, here it can correspond to what? 1.2. Now this 1.2, it will indicate the relative density of that liquid. So that's the way how the hydrometer functions. You understand? Okay, thank you for watching. Don't forget to subscribe. See you then in the next video.